All right, guys, so let's go over this warm-up. Let's see. Move this down here. Okay. What did you guys use for number 1? Law of sines or law of cosines? Sines, yeah. So the short way to remember which one to use is just try whichever one is your favorite law, which should be law of cosines because it's better. There's no flaw in it like there is in law of sines like we're going to see today. If I try to set this up with law of cosines, I'm going to see that, if I try to solve for like A or C, the problem is when I set up law of cosines is I still have a variable in there. So like A squared equals 15 squared plus C squared. As soon as I get that, I'm like, okay, wait, this is not going to work. Too many variables when I try to use law of cosines. So instead we use law of sines. We want to figure out that other angle first. What did you guys get for that other angle there? 81, yeah. Just subtract from 180. So then that's angle B. So our law of sines says 15 over sine 81 equals A over sine 42. And 15 over sine 81 equals C over sine of 57. So notice what I did here, I kind of shortcutted the process. Instead of setting up like all 3 parts of law of sines, I just picked the 2 that I'm going to solve. For both of them, we want to use like 15 over sine 81 because that's the information that we're given. These are one-step equations that you learn how to solve actually even before Algebra 1. To get A or C by itself, what's our one step?
Multiply by sine 42.
Yeah. Multiply both sides by sine 42. Multiply both sides by sine 57. Okay. So in Desmos, when I did that, here's what it looked like. Angle B is 180 minus 42 minus 57. A equals 15 over sine B times sine 42. C equals 15 over sine B times sine 57. Took me about 30 seconds to do that one once I had it set up. So we get 10.162 and 12.737. Any questions on number 1?
What did you want us to round it to?
3 decimals. Yep. You guys can close your computers, by the way. You don't need them anymore. Okay. For number 2, what did you guys use? Sines or cosines? Cosines, yeah. So if A is 25, B is 32, C is 67. Again, if I try to set this up with law of sines, I immediately have a problem. I only know one angle and I don't know the side that goes with it, opposite. So like, I don't know A, but I do know side A. I don't know side C, but I do know angle C. So law of sines just has too many variables, it won't work. But if you want to be a little more efficient than just like try something and hope that it works, we have law of sines, law of cosines. Which situations work for law of cosines? Side, 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 and what was the other one? Side, angle, side. Yeah, that's what we have here. For law of sines, what do we use this for? Angle, side, angle.
Angle, side.
Yep. And then one more that we're going to do today.
Angle side side.
Angle, side, side. Okay, and that's the one that doesn't work in geometry, but we're going to figure out how to use it this year. Let's see. The only thing that's missing from geometry that proves triangles congruent, anyone remember? There's like 5 ways to prove triangles congruent. We're missing one. It does not use A or S. Hypotenuse leg, which only works for what kind of triangles?
Right.
Right triangles, yeah. For right triangles, we shouldn't use law of sines or law of cosines. We should just use regular old SOHCAHTOA. So you will see some right triangle problems on our test, on our quiz. Just use sine, cosine, and tangent like you did back in the day. Okay, anyways, when we use law of cosines on a side angle side situation, what do we solve for first? Yeah. And so we use this, c squared equals a squared plus b squared minus 2ab cosine c. Okay, I think you guys have got the hang of law of cosines pretty good. In Desmos, here's what it looked like for me. I have a equals 25, b equals 32, big C equals 67. And then here's me solving for the side first. Just plug it into that square root, storing it as little c. And then I've got my two cosine inverse fractions here. When we solve for angle b, it should go b squared minus a squared minus c squared over 2ac. And then when I'm solving for a squared goes first, and b and c are the second two on top, and the two letters on the bottom. We've done a lot of practice, law of cosines. So I got 67.011 degrees and 45.989 degrees. Questions on that one? All right, our test is going to be like this, where I'm just giving you like angles and sides, and you have to figure out what law to use, and then you have to solve the rest of the triangle. So yeah. Okay, let's talk about the ambiguous case. That's annoying. I need to reorder those pages. I'll give you guys some notes here. So, like I mentioned last class, the problem with angle side in geometry is that there's two possible triangles that we can form with the information that we're given. Sometimes, but not always. There's actually a few different combinations. You want more? All right. So that's why it's called the ambiguous case, because it could be one, could be the other, depending on the information that we have. So it basically works like this. If we have a triangle with that information, like that angle has a fixed size, those two sides, they have to stay that length. What we're not told is how long this bottom side is, and we're not told what these angles are. So what happens is, try and make this as close to the exact same size as I can. What happens is this other side here can go in two places. It can basically swing over and fit in the same triangle, or and now creates a different triangle. So basically, you have one big triangle and one little triangle that's created when you have angle side. But it's not true all the time. And so that's what we're going to look at today. So first of all, always draw your triangles arranged like this when you have angle side. So you're given side 1 and side 2, and put a little gap in there. Drawing it like this, you don't have to, but you have to. What this is a strategy to make it easier. In a math problem where we have multiple moving parts and changing variables, you want to keep as much of the problem consistent as you can to make life easier. So we have our angle, we have our two sides arranged like that. There's a few different things that can happen here. One situation that we're going to give you let's call it side 2. The first situation is that side 2 is actually shorter than the height of the triangle. The height of the triangle is always going to be known, and it won't be able to change because that angle at the bottom has to stay at however many degrees it is, and that side has to have the same number of degrees. So we're going to be able to find the height of the triangle. If side 2 is shorter than the height of the triangle, it's basically not long enough to reach the ground. We're going to have 0 triangles in this situation. Because side 2 is not long enough. The second situation that we're going to have is, instead of calling it A, I'm just going to keep calling it S2. I'm just going to shorten it just a little bit here. Is if S2 is exactly the same length as the height, in which case our triangle actually looks like this. So it's like if that piece right there swings in and basically just comes down at one point right there. We have one triangle, and it's a right triangle. And in this case here, we should just use SOHCAHTOA. No.
If we go back to case 2, if there's no triangles, does that mean like there's nothing to solve and it ends up being undefined?
Yes. If there's no triangles, like the problem's over, you've won, you don't have to solve. Yeah, that's an important distinction. Okay. Case 3. So that's S2. That's S2. This is S1. Let me just rewrite this here. So, in this case right here, S2 is longer than the height but shorter than the first side. This is the situation. This is the one to worry about. This is the one where we have two triangles. Because the other triangle, let me try and draw it a little better there. The other triangle looks like this. So again, this is why like we always want to draw it the same way, because we have some moving parts here, so it's just going to make everything easier. The first triangle that's formed is always like a big triangle. And the second one is a smaller, obtuse triangle. Meaning that angle right there is going to be an obtuse angle. And again, I know it's a little abstract right now, but basically just laying out all the possibilities here so that we can do some examples. So the big triangle, this triangle right here, this angle right there, that could be an obtuse angle. It may or may not be. We don't know. But the reason I'm emphasizing that this is a smaller obtuse triangle is like that angle right there is guaranteed to be obtuse because that side swings in, and so it's greater than 90 degrees. Okay. In this situation, we need to solve both, which I said already. Great. Okay. I forgot to say. I bet I said that. Okay. So, case 3, part 2. Why would you call it case 3, part 2?
That's similar.
Yeah, it's similar, I guess. Let's just call it case 4 because it's the fourth one. I didn't write these notes. Weird. Okay, so case 4, we have our angle, we have our side 1, and side 2 is longer. I'm going to exaggerate that even more. So as we look at this, we can see like I really exaggerated how long S2 is going to be. Could it swing over here and make a second triangle? No, it's way too long. There's not enough room. Like if that side swung over, it'd be kind of like poking out of the triangle like that. It'd be weird looking. So there's only one triangle in this case. So we're saying side 2 is greater than the height and side 2 is greater than side 1. But really the only part that matters is that side 2 is greater than side 1. Because if that's true, it's going to be greater than the height. We don't need to find the height in this scenario. Okay, so those are our 4 possibilities. And that's what we have to get familiar with, and this is why this part is kind of difficult because you have to keep all these things straight. And then once we actually solve for two triangles, it's a little crazy, but it's not too bad. Actually, having Desmos is going to be really helpful. Here's what I want you to do right now. I want you to turn to your neighbor and I want you to summarize all of these four cases in your own words. Ready, set, go.
So it's just like, this one is if side 2 improves, then it's not just and then if the first area is the same height, then it's a right triangle.
Nice. So I think just especially with something this abstract, we haven't done any numbers yet. It's helpful for you guys to think about it and try and explain it. Why could there be two triangles? To kind of summarize all this, it's all about side 2. Is it the right length where it could swing in and make a second triangle? And in summary, what we have is case 1, too short. Case 4, too long. Case 3, the Goldilocks case. Just right. Case 2 is rare. That's hard to read. I basically just use case 2 to see if you're paying attention. Okay. Theory can only take you so far. Let's do some examples. Okay. I'm gonna actually change angle A and not make it 120 because that's like a crazy example to start with. Let's say it's 80 degrees. The same thing is gonna happen. So here's how this would go. First of all, I look at it. I look at the letters there and I see, okay, I have one angle and two sides. Is this a guarantee that it's angle side side? No, not necessarily. We also have what other possibility?
Side angle side.
Side angle side. Yeah, that's also one angle, two sides. Okay. Without drawing it, can you guys tell if this is which one this is? Talk about it with your neighbor.
Angle side side.
¿Cómo sabes? How do you know?
Because one of the angles we're given is also a side. Like, we're both given capital A and lowercase a.
Yeah. Very good.
And I drew it, but
And you do it.
I figured it out before.
Yeah. Yeah, it's great. Okay. Do we agree that this is angle side side without drawing it? Yeah. So what you want to look for is that we have angle A and side A. That means they're opposites from each other. Our side angle side example from the warm up, we had A, B, and angle C. It was between the two sides. So that's a quick way to recognize. If you don't recognize it, it's fine. You draw it, you see it's angle side side. You might need to erase your drawing to make sure it looks, like the way we're supposed to set it up, but that's fine. It's fine if you don't notice right away. So, again, always draw it like this. 80 degrees, that's angle A. So we're gonna put B right here, 36. And we're about to draw A. Is A longer or shorter than 36? Longer. The more you can draw this to scale, the more helpful it will be. I know my 80 degrees is not quite to scale. But if I put 45 right there, and that's B, and that's C, and that's C. I actually do recommend leaving a little gap until you're sure. So turn to your neighbor. How many triangles? What case are we looking at? Okay, what case is this? This is case 4. Yes, very good. So we see that side opposite, that's side number 2, it's the opposite side, that's the one we care about. It's too long. It's longer than the other side, there's not enough room for it to swing over right here and make another triangle. In this case, this is case 4. Case 4. We do not need to find the height. We don't need to worry about the height because we're in case 4. There's just one triangle. We don't have to worry. Case 4 is the easiest. Well, case 1 is the easiest. So we're just going to solve using law of sines. And we're going to start with angle B. Why would we start with angle B? That's all right. Thoughts? Why are we starting with angle B? Why not angle C or side C? Yes. Yep. We know some information to go with B. Angle C and side C, we got nothing. That's going to have to be our last step. Okay, so we set it up. Sine B over 36 equals sine 80 over 45. I put B on top because that's what I'm solving for. Turn to your neighbor, how do we solve? Okay, so when we solve, we got to get B by itself, multiply both sides by 36. Sine B equals 36 times sine 80 over 45. And then how do we get B by itself? What's our last step? Sine inverse, yeah, exactly. So B equals sine inverse of all of that. Same as all of our other examples, like solve it all the way first and then type it into Desmos, which we'll do later, but I'll do it today. I'll do it for the notes. Oops, sorry. Okay. So B equals arc sine. All right. This new Windows operating system, I don't understand how it works. So 36 sine 80 over 45. So B equals 51.985 degrees. Okay. Same as before, I'm just calling it B. I need to find, now I have two angles and two sides. What would be my next step? Yeah, the next angle, right. And how would I find the next angle? Yeah. So 180 minus B minus 80. So angle C is 48.015. Degrees. I think I have to put it first. Oops. Capital C equals that. Okay. Now, to solve for side C, we know what to do, right? This is the same as what we saw in the warm-up. We would do C over sine of C equals 45 over sine of 80. It's better to use the given information. And then we just multiply both sides by sine C. So 45 divided by sine 80 times sine of C. So 33.966. Yeah, not that bad, right? Just had to do a little sine inverse at the beginning. Not a huge deal. Let's look at example 2. I'll just tell you right now, as we look at all of these examples, except for one, well, there's 3 examples here. One of these is not angle side side. Which one? You can look at your paper too if you can't see clearly up here. 4, yeah. 4's got 2 angles and 1 side. Okay. Maybe we'll change example 4, depending on what these 2 cases do. Okay. So number 2 here, we've got our angle, 43. I know 186 is going to go opposite 43, because that's angle B, and that's side B. I'm going to put 249 right there. Okay, turn to your neighbors. This case 1, 2, 3, or 4. Okay, you guys are getting stumped on the right part. What information are we missing that we need to know? The height. We need to know the height of the triangle, exactly. This is definitely not case number 4. Okay, dang it, that's the easy one. Okay, so we need to find the height of the triangle. Finding the height of the triangle is not too bad. It's right there. Do you see what kind of triangle we're making? Right there. Right there. You see what kind of triangle that is? That's a right triangle. Okay? So if we're solving for the side, the height of the triangle, we do h is opposite, adjacent, or hypotenuse. Opposite, right? So we want to use, and 249 is the hypotenuse. So we want to use sine. Oh, look at that. Sine 43 equals h over 249. So h just equals 249 times sine of 43. So we're just using SOHCAHTOA. Specifically, the sine part of it.
How'd you know it was sine?
As I look at it here, we have our angle, and h is opposite, and 249 is hypotenuse.
Oh.
Yeah. It'll always be sine, also. So, KAHTOA. We are gonna do that here. Let me just delete these. 249. Oh, hello. 249 sine of 43. Let me just double check that I'm in degree mode. I am. So our height is 169. We don't need to round that at all. We just need a ballpark here. So turn to your neighbor. What case is this? Okay, which case is this? This is 3. This is 3. Okay, seatbelts on. All right. There's two triangles. One of them looks like this. The other one looks like this. I like to call these triangle number 1 and triangle number 2. Triangle number 1 is the same process as last time. So triangle number 1 is going to go the same as case 4. You guys take 2 minutes to solve triangle number 1. Ready, set, go. You can use your computers. Partner up. Use one computer per group, per partner. Hey, real quick, as you're doing this, if you type like capital C and then type the number 1 afterwards, it'll do like a little subscript 1. Do that as you're solving this, like C1, A1, A1 for the other one. Just type the number afterwards, you'll see it automatically does subscript. Why are we subscripting our letters here? There's 2 triangles, yeah. So it just looks like this. Like if I type C1, it goes like that. I got 60.045 by the way.
Yeah.
And you can just like, you don't have to like go back up to regular script. You can just like type and then type equals. It'll figure out what you're trying to do. Okay, so these are the actual correct answers now that I do it right. So it's the same process as before. In Desmos, I did C1 equals arc sine 249 sine 43 over 186. Solve for A1 by subtracting from 180. And I found little a by setting up my law of sines just like we just did. Okay? So, here's where it gets a little crazy. We need to find the second triangle. Let me just erase this right here. So, in triangle number 2, What's happening here is the 43, let me just zoom all the way in. The 43 is staying. The 249 is staying. But this 186 right here is swinging over. And it's going to go there instead. Are all those numbers right? Okay, sorry, yeah, I just forgot what letters were which. Yeah, C, B. Okay, thank you. So that side B is swinging over, the 186 is swinging over. And so what our triangle looks like now, this is triangle number 2. Is it looks like this. It's a smaller acute triangle. Okay. So, where would we start if we're solving triangle number 2? Yeah.
Angle C.
Yeah, exactly. We'd find angle C, same as before. Okay, now I'm going to write some stuff here in pencil that I'm going to erase. So here's the problem. Here's the flaw with law of sines. My setup, wouldn't it be the exact same, right? Sine of C over 249 equals sine of 43 over 186, right? Doesn't that match the picture? I multiply both sides by 249. I take the sine inverse. So it'd be like 249 over sine 43 times sine 43 over 186, right? Like that would be my setup. But we already typed that into Desmos. And it told us that C1 was 65 degrees. And as I look at this picture, is C2 65 degrees? It's definitely not. It's definitely an obtuse angle. The problem is I don't know another equation to set up. Like law of sines, here it is. Law of cosines is not going to work. But it's not giving us the right answer. This is the flaw in law of sines. Sometimes it won't give us the right answer. Turn to your neighbor. Why? Why is this happening? I'll tell you, it's because we're using sine inverse. You may need to ask some people that are in Club Hundo for Unit 7, which is a lot of people. What's up with sine inverse? It is restricted. Where is it restricted? Yeah. So that's negative 2 pi to 2 pi, or sorry, negative pi over 2 to pi over 2. But in degrees, what do we call those angles? Yeah. It's restricted from negative 90 to 90 degrees. Which means that if we use sine inverse, it can never give us an angle that's greater than 90 degrees. It just can't do it. Nice job, Jeff. This is the problem with law of sines. Sine inverse restrictions don't match what we need right here. So here's what we have to do instead. We basically just can't use law of sines to find angle C2. So let's see. Sine inverse, let me write that down. Sine inverse can't find obtuse angles. Because its restrictions are from negative 90 to positive 90. Oops. So instead, here's what we're going to have to do. We're going to have to look right here at what's going on right there. What we're actually forming when we swing that side over, I love geometry, is we are forming a little isosceles triangle right there. Which means that the angle that we found for C1 is right here, but it's also right there, because the base angles of an isosceles triangle are congruent. Which means that the angle that we want, C2, is right here. And if we know C1, how would we find C2? Subtract from 180, because they're forming a linear pair. So that's how we have to get over to the second triangle. Now, you don't have to remember all that every single time. All we have to do is subtract C1 from 180 to find C2. And then from here on out, it's actually going to be the same process. So when we're doing triangle number 2, we do C2 is 180 minus C1. And check out how this is going to go in Desmos. I type C2 equals 180 minus C1. So it's 114.077. I take this. Now we just repeat the steps. I take where I solved for A1. Now I make it A2 equals 180 minus C2 minus 43. Bless you. I take this where we found little a. Make that A2. Because I already had it all typed, I'm just changing the subscript. Because our process is now the same. So C2 is 114.077. A2 is 22.923. And lowercase a2 is 106.226. Okay, so let me just recap that so we don't get lost in the weeds here. When I look at triangle number 2, I know that the first angle that we found was 65. I'm just going to use rounded numbers here. So there's like a 65 on the outside there. Subtract it from 180. So we get an angle that's roughly equal to 115. Now that I'm looking at this triangle, our next step would be to find the third angle, right? Subtracting all those from 180. 180 minus 43 minus 115. Okay, great. We do that. It's roughly 23 degrees. Last but not least, we're looking for lowercase a2. A2 over sine of 23 equals 186 over sine of 43. And so I'm just multiplying by sine 23 on both sides. So notice it's exact same solving process to finish the triangle that we just did. Which is why on Desmos I could just change all the numbers. Okay. It's confusing at first, but it takes a couple reps and you get the hang of it. This is the key step right there. Okay. Let's look at example 3. I haven't done this one in a while, but I have a feeling it's going to be quick. Turn to your neighbor, what case is this, or what would we need to do? Okay, what case is this, or what would we need to do to find the case? We need to find the height. Okay, find the height. Did you guys get that the height is roughly 82? So remember our setup here. We use that right triangle right there. Oops. Sine 42 equals h over 122. So we want 122 sine 42. So what case is this?
First one.
This is case 1. How many triangles? Okay, if there's no triangles, there's no math problem. So we're done. That's it. Please don't try to solve a situation where there's no triangles. It won't work. Every year someone tries to do it on the test. We are done with that problem. Okay. I'm going to change this example right here and have you guys do it. Let's see. C is going to be 46 degrees. Little a is going to be 10. And little c is going to be 9. If you were me, what case would you have just made up? Yeah. Mike, do you have a question? Huh? I would do that if I'm nice, but I'm not that nice. Yeah. This is 2 triangles. Okay, solve this.